One of the most eagerly anticipated astronomical phenomena is the bombastic impact of the star known as Betelgeuse in the stunning shoulder of Orion. Betelgeuse is a remarkable, purple, very large star that is drawing nearer to a momentous, crowned brilliance. This star, due to its massive size and brightness, has captivated astronomers and stargazers alike for centuries. As it draws closer, it offers an intriguing case for observation, sparking widespread interest across the scientific community. Betelgeuse is a highly dynamic object for stellar research and observations, largely due to its variable nature and its rare designation. Stars that bear the name Alpha are typically regarded as the most significant members of their star systems, with Alpha Orionis, better known as Betelgeuse, being no exception. The star's prominent position in the constellation Orion, coupled with its deep red hue and immense size, makes it a fascinating subject for astronomers. It is, in fact, one of the brightest and most recognizable stars in the night sky, and its variable nature adds an element of unpredictability that continues to intrigue scientists. The name Betelgeuse might sound unusual, but it refers to the same star as Alpha Orionis, commonly known as Betelgeuse. Betelgeuse is part of the Orion constellation, and its name is derived from Arabic, meaning the armpit of the giant. The star is often depicted as the right shoulder of Orion in various mythologies and constellations, symbolizing strength and grandeur. Historically, Orion has been associated with a giant, a hunter, or a heroic figure, and as such, Betelgeuse is frequently linked to these powerful symbols. Astronomers have attempted to pinpoint the exact distance of Betelgeuse from Earth, but there is still some uncertainty. Current estimates suggest it lies between 430 and 724 light-years away, which places it among the relatively nearby stars. Despite the ambiguity in its precise distance, it remains the closest red supergiant to Earth, making it an important object of study in stellar evolution. Betelgeuse is an enormous star, about 16.5 times the mass of our Sun and with a radius approximately 1,000 times larger. This colossal star is far more luminous than our Sun, boasting around 126,000 times the Sun's brightness. However, its surface temperature is considerably cooler, with a temperature of approximately 3,600 Kelvin, which is significantly lower than that of the Sun. This lower temperature contributes to its characteristic reddish appearance, which sets it apart from the bluer, hotter stars like Sirius. Despite its lower temperature, Betelgeuse is still one of the brightest stars visible from Earth, and it plays a significant role in the night sky. Its brightness fluctuates due to its status as a variable star, meaning it changes in brightness over time. This variability is caused by pulsations within the star, which can lead to dramatic changes in its luminosity. These fluctuations were particularly noticeable in 2019 and 2020, when the star experienced a temporary dimming, sparking widespread interest and research within the astronomical community. Betelgeuse is often referred to as a red supergiant, which is a phase in a star's life cycle that occurs when it has exhausted most of its hydrogen fuel. At this stage, the star expands dramatically and cools, resulting in the large, reddish appearance characteristic of red giants. While Betelgeuse is in this late phase of stellar evolution, it is still a relatively young star, at an age of around 9 to 10 million years. Stars like Betelgeuse are much younger than our Sun, which is over 4.5 billion years old and still in its main sequence phase. One of the most intriguing aspects of Betelgeuse is its impending fate. Like all red supergiants, Betelgeuse is on the verge of exhausting its core fuel. As it burns through its hydrogen, it will eventually begin fusing heavier elements like helium, carbon, and neon. This process will continue until the star has fused enough material to reach a point where it can no longer maintain its outward pressure. The star will then undergo a catastrophic collapse, triggering a massive supernova explosion that will release more energy than 10 billion suns. This explosion will mark the end of Betelgeuse's life cycle, but it will also produce a brilliant display visible across vast distances. The process leading to this eventual supernova is known as the death throes of a star. During this period, the core contracts while the outer layers expand and cool. Betelgeuse's surface will continue to pulsate, and its size will increase even further. If it were to replace our Sun, its immense size would cause it to engulf the inner planets, including Earth, Venus, and Mercury, likely consuming them entirely in the process. Before it reaches this ultimate end, Scarab-Juse will undergo a series of changes. As it nears the end of its life, it will continue to lose mass, with material being ejected from its surface in all directions. This ejected material creates a surrounding cloud of gas and dust that envelopes the star, and it is this material that can sometimes obscure the star's full brightness. The cloud is immense, spanning tens of astronomical units, AU, and AU is the average distance from the Earth to the Sun. This surrounding envelope contributes to the star's variable appearance and the difficulty astronomers face when attempting to measure its true size and luminosity. Scarab-Juse's variable nature also leads to fluctuations in its light output. Its darkening and enlightening cycles are part of this variability, with the star dimming and brightening over periods of several months. These cycles occur every 100 days or so, adding an additional layer of mystery to the star's behavior. Researchers continue to study these changes to better understand the underlying processes at work within this massive star. The star's future supernova event could occur at any time in astronomical terms, but it is difficult to predict precisely when it will happen. As a relatively young star in the red supergiant phase, it still has millions of years to go before it reaches its final stage. However, once it explodes, it will undoubtedly have a significant impact on the surrounding interstellar medium, enriching it with heavy elements that will eventually form new stars, planets, and other celestial objects. One of the challenges astronomers face when studying Scarab-Juse is the star's vast size and the complex environment surrounding it. The star's circumstellar envelope, consisting of gas and dust ejected from its surface, interferes with measurements of its actual size. Additionally, the star's variability in brightness makes it difficult to pinpoint its exact characteristics, such as its radius or luminosity. Advances in technology, such as the use of interferometers and advanced telescopes, have provided more detailed observations, but there is still much to learn about this fascinating star. In conclusion, Scarab-Juse, Betelgeuse, is one of the most fascinating and dynamic stars in the night sky. Its enormous size, variable brightness, and impending fate as a supernova make it an essential object of study in modern astronomy. Whether it's the dramatic changes in its luminosity, its impending death as a supernova, or its association with the legendary figure of Orion, Scarab-Juse continues to captivate scientists and stargazers alike. As we continue to study this extraordinary star, it offers us a window into the life cycle of massive stars. Top that affirmed up at $30 Australian dollars from the celebrity into the encompassing air, the size of this mass discharge, which transformed into one of the different occurrences inside the climate of Scarab-Juse, in contrast with the distance between the sunlight and Neptune. Stargazers have seen as something like 6 shells, which include creepy-crawly Jews, through watching out for the secret of mass-intense trouble over the previous periods of a star's life. It very well may be possible to pick the legitimization for those prominent Goliaths' horrendous loss along the celebs, with issues and stresses raised with respect to complex added substances of bug Jews, expanded environmental factors. Remarkable giants assume a significant part inside the reusing of matter that makes up universes. By the way, it is still shady how mass is lost through various kinds of progress and interferometric approaches. Experts can now make do with this trouble. Region experts applied Hubble and other observatories to narrow down that the superstar pardoned a brilliant arrangement of its recognizable surface in 2019, making a huge floor mass boat off this, which, until recently, had never been found in a star's lead. Our Sun steadily dispatches bits of its thin out-of-the-way environments, the corona, in a capriciousness known as coronal mass ejection, CME. Those events are widely more significant and weaker than what became seen on Scarab-Juse. The bug-Jew floor mass grass shot out 400 billion times greater mass than an all-around average coronal mass ejection CME, which peaked by mid-February 2020. Insect Jews had lost around triple the amount, with its brightness going from 0.5 to 1.7, causing it to start to diminish quite in October 2019. By February 17, 2020, Insect Jew's brightness had been normal for almost 10 days, and the VIP had begun to enlighten at its captivating How insect juice, regardless of its cosmic distance and intricacy, stays a subject of serious review and perception, its variable nature, throbs, and strange ways of behaving, continue to enamor cosmologists and devotees alike. As we dive deeper into grasping this heavenly giant, we unwind not just the components overseeing its presence, but also the more extensive cycles shaping the universe. Insect juice remains as a demonstration of the stunning powers at play in the universe. Its approaching destiny, marked by the expectation of a fantastic impact, highlights the dynamic and ever-changing nature of divine bodies. From its humble beginnings as a hydrogen-powered star to its possible end in a destructive blast, bug juice encapsulates the pattern of creation and annihilation that describes the universe. As we endeavor to understand the complexities of insect juice and other stars like it, we gain significant insights into the crucial functions of the universe. Each observation, each revelation, brings us closer to unwinding the secrets of the universe and our place within it. So, let us continue to look into the depths of space to study the stars that spot the night sky, to wonder about the magnificence and intricacy of bug juice and beyond. For in our journey for knowledge, we open the secrets of the universe and set out on an expedition of discovery that exceeds all scientific limitations. Scarab juice, settled in the shoulder of Orion, commands attention not just for its sheer size and brightness, but also for its mysterious behavior. As one of the most conspicuous stars in the night sky, it has entranced space experts for a long time. Its changeability, throbs, and periodic diminishing episodes have started extraordinary investigation, leading to a more profound understanding of heavenly evolution and dynamics. Notwithstanding its distance of many light-years from Earth, creepy-crawly juice holds a prominent spot in both scientific investigation and cultural legend. Concentrating on bug juice gives a window into the life cycle of enormous stars, with its tremendous size and massive energy yield. Insect juice serves as a vital example of how stars evolve over a long period of time, from its development in clouds of gas and dust to its possible death in a grand cosmic explosion. Creepy-crawly juice embodies the emotional changes that shape the universe. By observing and investigating its conduct, cosmologists gain insights into the fundamental processes driving heavenly evolution and the formation of elements essential for life. The new perceptions of scarab juice, experiencing variances in brightness and mass launches, have added new layers to our understanding of heavenly dynamics. These peculiarities, while not fully understood, offer tempting hints about the internal functions of huge stars. Through advanced telescopes and instruments, researchers continue to observe scarab juice and other celestial objects, hoping to unwind the mysteries of the universe. Beyond its scientific importance, scarab juice holds cultural and symbolic significance in various societies, from ancient civilizations who incorporated it into their myths and legends, to modern astronomers who study it with cutting-edge technology. Bug juice has captured the imagination of people since the beginning of time. Its name, derived from Arabic and Greek origins, reflects the various cultural influences that have shaped how we perceive the universe. In the vast field of space, scarab juice remains as a beacon of wonder and exploration. Its brightness illuminates the night sky, inspiring curiosity and awe in all who gaze at it. As we continue to unravel the mysteries of scarab juice and the universe at large, we embark on a journey of discovery that expands our knowledge and appreciation for the beauty and intricacy of the cosmos. The ongoing investigation of scarab juice embodies humanity's insatiable curiosity about the universe and our tireless quest for knowledge. With each observation and revelation, we peel back the layers of mystery surrounding this divine giant, uncovering new insights into the nature of stars and the universe itself. From its inconstancy to its approaching destiny, insect juice enthralls our imagination and drives our quest to understand the central forces that govern the universe. As technology advances and our understanding of astronomy expands, we stand on the brink of extraordinary revelation about bug juice and other stars like it. With space telescopes, high-resolution imaging techniques, and complex programmatic simulations, astronomers can peer deeper into the heart of creepy-crawly juice than ever before, uncovering its structure, creation, and behavior in great detail. However, the study of creepy-crawly juice is not just about unveiling scientific mysteries. it is also about exploring the broader implications of our place in the universe. By understanding the life cycle of stars like insect Jews, we gain insights into our own origins and fate. We are stardust, formed in the fiery furnaces of enormous stars like bug Jews, and our world is intimately connected to the cycles that shape the universe. In the grand tapestry of the cosmos, Scarab Jew shines as a symbol of astronomical excellence and intricacy. Its brightness illuminates the night sky, reminding us of the marvels that lie beyond our world. As we continue to study and wonder about Scarab Jews, we embark on a journey of discovery that transcends our reality, unlocking the secrets of the universe and broadening the horizons of human knowledge.